So what are we doing today, Shawn?
Yeah, we're at a nursery in Central Florida, in Plant City, Dover area, and we're going to go look at some Viburnum odoratissimum and Viburnum suspensum. So Viburnum is one of those plants where you can pretty much find it in almost any nursery in Central Florida. It's one of those top 10 woody ornamental plants. And we started seeing issues with it maybe 20 years ago or so. And we started seeing these foliar spots to blotches that would spread over the leaves. You'd have defoliation, you'd have leaves dropping off, you'd have spots that coalesce and form big patterns on the leaves. And then you'd also have tips burning back. You'd have shoot loss. In 1 gallon plants, it could take down the 1 gallon plant if it was soft. If you had new growth, it could take it down completely. On 3 gallons, you might lose some leaves and render it unsaleable. In propagation is where it's a really bad issue. In propagation, with the high humidity and constant mist, you have cuttings in there, and then I'd say within about a week, you can get total defoliation, and you can ruin your whole house of cuttings. You can lose that entire crop. It's very fast acting. If the combination of disease and temperature and humidity is correct, it'll wipe out those plants completely. Yeah, I'd say the younger they are, the worse the problem is. So propagation, it's extremely bad. 1 gallons, it can be serious. 3 gallons, it's less serious, more aesthetic, but you can still have some loss. And then I'd say as you increase 7 gallons and up, it's more of an aesthetic issue. In landscape plantings, though, I have seen it defoliate whole sections of shrubs. And usually in landscape plantings, you're looking for that nice shrub to offset the wall or to borders, and you really don't want giant holes where it's defoliated. Or I've even seen it take out a whole plant where you have to replant that, and then you're mixing sizes. So it can be an issue in the landscape as well. Where I've seen it mainly is in Viburnum odoratissimum and Viburnum suspensum. We've seen that commonly throughout Central Florida. And the Viburnum suspensum, you mainly find it growing under shady conditions, and Viburnum odoratissimum is more in the sun. You find those spots equally just based on humidity and disease pressure and time of the year. We're standing in a crop of 3 gallon Viburnum suspensum. And these are young Viburnum suspensum. These are 1 gallons that were stepped up to 3, and they've been trimmed back. So you see there's a lot of young growth coming out of the stems. And we don't see a whole lot of disease pressure here. There's some spots here and there, but they're doing a very good control on these diseases. There are other nurseries where it's extremely problematic and it's very hard to control. So with the production of viburnums, we get these spots here and there. And early on, when we diagnosed it, especially in propagation situations, we discovered it was downy mildew. And there's tools available, chemical fungicides, that are specifically tailored to those downy mildew issues. But as time went by, we started seeing that those chemistries weren't actually doing a fair job of controlling, and I got more feedback from clientele about this issue. So that's one of the reasons why we decided to take a look at this. Here we have a 1 gallon plant that was stepped up into a 3 gallon plant, and it's newly planted. It's probably maybe a month or 2 old. And it's been trimmed back, and you can see the new shoots coming out. But what we also see are some of these disease spots that we're talking about here on the leaves. There's a few on these leaves, and these leaves are showing symptoms as well. And what you don't want is, if this gets bad, you're going to lose all these leaves, and now all you've got are these stems with some new buds coming out, and there's not a lot of photosynthetic area for this plant to grow. So this plant is going to struggle to keep up with the other plants, and you're going to have a lot of unevenness in your crop.
Shawn reached out to me one day about this problem. We wanted to kind of look into it a little bit further to address some of the growers' issues that they're having. So we reached out to Dr. Gary Vallad in Gulf Coast Research and Education Center. So we applied for an FNGLA grant that helped us pay for some of the resources that we used in this research project. And basically what we wanted to do is look at different chemistries in the market that are available to nursery producers to see what efficacies are we seeing from these chemistries, but also to understand the disease itself, how it behaves throughout the year, what rates of disease, what kind of other management strategies that we can put in place to help us manage this problem. We were seeing maybe more downy mildew during early spring, wintertime when it's a little bit cooler, but the humidity is still high. You'll see some of these mornings when it's very foggy and the leaf wetness on the plant or the relative humidity is really high. That kind of gives the pathogens a very favorable environment to thrive in. Some other pathogens that we saw were throughout the summer or early fall, late fall. It's kind of in that area. We're not exactly sure when each of these pathogens exactly occur because it's we're here in Florida, weather it's kind of all over the place all the time, so we don't really know what to expect. But we have a good idea of what environmental conditions will conduce those diseases. The symptoms of Viburnum downy mildew are usually brown to purplish leaf spots. Sometimes the purple might not be that much apparent. If the symptoms are very severe, you might see the tips of the leaves are completely burnt and just leaves are completely just defoliated and burned out because of how fast sometimes the Viburnum downy mildew spreads. On the underside of the leaf, you might be able to see sporulation of plasmopara depending on the weather conditions. Sometimes it can be very challenging to see the sporulation. Here is an image of the sporulation on the underside of the leaf with a hand lens, and here is the sporangia and sporangiophores under the microscope. And here in the top you can see how bad the disease can get, sometimes defoliating whole hedges of plants. But we also saw a lot of different symptoms out in the field. And here you can see a wide range of different types of symptoms that we were able to see on the viburnum plants. And here's a close-up under the hand lens that you can see the different types of spots with some sporulating structures that you may be able to notice here and here. We were able to isolate from these different types of leaf spots that we were able to collect from the nurseries. We were able to isolate 5 different pathogens. So the plasmopara, the downy mildew, the Coltotricum, Coronispora, Phylosticta, and Cercospora. We were also able to isolate Pistolochopsis, but that might have been secondary. So the way we went about our fungicide efficacy trials is that we looked at the fungicides or chemistries that are registered for use on viburnum that are available to the nursery growers. And by any means, this is not a comprehensive list, but those are some of the main frag groups that we thought that might be relevant and might be useful to this research trial. So our first nursery trial was conducted in the summer, and we looked at the few active ingredients that are a broad spectrum or targeting true fungi or oomycetes. In this table, you'll be able to see the different active ingredients we looked at in our first trial with the different rates and from the different frag groups. And when we looked at the area under disease progression curve, notice here this is the water control. The A to PC range is the above the thousands. The broad spectrums those 2 broad spectrum, the copper sulfate and the mancozeb, didn't perform very well. The oomycete AI didn't perform very well, those blue ones. And the true fungi targeting chemistries, those did the best, which was a little bit surprising because initially at that point we were thinking we're mainly dealing with oomycetes. We're mainly dealing with a downy mildew, which is an oomycete. So to see those true fungi targeting chemistries performing the best, that obviously that means we might not have downy mildew, we might have something else on those plants. And in conjunction with that, we were also doing the lab sampling and also doing the growth chamber pathogenicity test to confirm the pathogenicity of those fungi that we were able to isolate. So this table is just narrowing down those chemistries that we looked at in the previous table to kind of have a better idea and be able to visualize a little bit better. So again, those true fungi targeting a active ingredient did the best. The broad spectrum didn't do very well. Only a few of the oomycete targeting AI reduced the disease a little bit, but it was still an insignificant reduction in disease. And obviously, the diseases that we saw were Cercospora, Cultotricum, Cornuspora, and Phylostecta, which we mentioned before. So we took that group of AI, the smaller group that we focused on, we wanted to retest those again in the field and have a better idea of how they respond when we replicate the trial. So we went back in the fall, we did another field efficacy trial. There is one difference from the previous trial, that the top guard was applied in a drench instead of foliar application. And looking at the area under disease progression curve for the water control was significantly lower than the first time we ran the trial. So we didn't see a whole lot of disease pressure in the fall. So it would have been nicer to see a little bit more disease, so we were able to differentiate a little bit more between those chemistries. But again, we were able to isolate again from samples taken in that trial those same pathogens, the Cultotricum, Cornuspora, Phylostecta, and Pistilliciopsis. So what we learned from this project is that there are many pathogens that can cause leaf spots on Viburnum or leaf disease on Viburnum, and they can also be detrimental to the Viburnum crop production throughout the year. Depending on the environment, if it's conducive, you might lose a whole crop of Viburnum plants. Also, correct identification was key in disease management. In this case, that's what we learned especially from our first trial, trying to use a lot of oomycete, trying to test a lot of oomycete, assuming that is downy mildew, while we were able to isolate multiple pathogens. You may be able to use a hand lens to identify downy mildew disease in the field, but it can be also a little bit tricky to differentiate that from different leaf spot symptoms out there. It might be even more difficult to identify or differentiate between the different true fungi that we're able to see in the field with a hand lens. And again, weather was a key to this disease. You saw in the summer when it's raining a lot, it's very humid. It is a very conducive environment for this disease to thrive, and we were able to see quite a bit of disease out there and disease pressure out there in our nurseries. Versus that fall, it was a little bit drier, so we didn't see as much disease pressure out there. So in addition to using the right chemistries based on the diseases and the correct identification of those diseases in the field, there are some other things that you might be able to do in a nursery to reduce and manage disease. If possible, to avoid overhead irrigation, that might be a very great solution. However, that might not be economically feasible. So you might want to space out plants to reduce the leaf wetness and reduce relative humidity around the plants to make a drier environment and not so favorable for those pathogens. So it's also very important to propagate from clean plant material and use clean, sanitized propagation tools. There might be some differences in the susceptibility of the Viburnum plant species. However, we're not sure yet of that. That might be something that we explore in the future. Also, we're in the process of repeating some of these trials and trying to see what's out there in a different season and test some of these chemistries again to get a better idea. And hopefully we'll see a little bit of disease pressure this time that might be able to give us a better idea of how these chemistries are performing. If you have any questions about this research project or viburnum disease management, please reach out to our team and we would be happy to answer any questions.